This video, examples 4 and 5 really focus on section 5.8. For example 4, it's asking us to find all the possible rational zeros. So if there are irrational zeros or imaginary or complex zeros, they're not going to show up. This only works when we're talking about rationals. Now, what the rational zero theorem says is basically if I look at the last number and then I also look at the first number in the polynomial, if I divide those factors, I can find all the possible rational roots. Again, this theorem, this idea is really used before the idea in the dawn of graphing technology. But what it does is normally we represent the last number as p, and in the theorem you're going to see the first number as q. And what we would first do is, what are all the factors of p? Well, factors of p would be plus or minus 1, plus or minus 2, and plus or minus 4. So those would be all the possible factors of p. And then we would list all the possible factors of q. So q, which in this case is 3, those factors would be plus or minus 1 or plus or minus 3. It does help that 3 is prime. Now, what we would do then is we want to find all the combinations of p divided by q. Well, okay, if we look at this, the first round is if q's on bottom. If q's on bottom, it's basically divided by 1, which means it'll be plus or minus 1, plus or minus 2, and plus or minus 4. Okay, and then we get into what's going to cause the fractions. So in this case, now 3 is on the bottom. So that's plus or minus 1/3. That'll be plus or minus 2/3. And finally, plus or minus 4/3. Now, the way it works is, in this giant combination and list of numbers here, the rational roots have to exist in one of those combos. Again, this was helpful when we were trying to figure out how to graph, and we didn't have a graphing calculator. We at least had a rough idea of where to start looking for the rational zeros. Now, when we go down to example 5 here, okay, we are given a shape, and we are told the volume of the shape, and what we want to find is the dimensions of the shape, so we got to solve for x. Now, volume, very simply, is length times width times height. Well, in this case, it tells me that my volume is 1,120 feet cubed. And that's equal to x times x minus 2 times x plus 4. Now, there are a large number of ways that you can solve this problem. The easiest for us, what we're really trying to do is we want to find when 1,120 is equal to that. Well, the great thing about the graphing calculator is we don't really have to solve anything. So we can go to y equals and set y1 at 1,120, and then we can go to y2, which is x times x minus 2 times x plus 4. Now, what's really cool about this is when we graph it, all you really got to find is the intersection of the two lines. Now, if we hit graph, it should be pretty obvious that in our graphing window we're not going to see what we need to see. So there's one of the equation lines coming through, and so we can see it's kind of an arc. What we're going to want to do is adjust the window. First of all, we said y has to be at least 1,120. So we're going to go down to our y max here, and first, whoops, too far, I'm going to adjust my y max to be like 1150. That way I can see what's going on. Okay, so that changes my y max. So if we regraph it, let's see what that gives us. Oh, there's my blue line of what the values equal. And there's a big old parabola sorted down there, but we can't really see what's going on. So what we're going to have to do is we're going to go to the window, and we need to really kind of change the x scale here. I'm going to try -15 for my x-min, and we're going to switch my x-max to +15, and just see what kind of window that gives us. Okay, so again, there goes the blue line, and somewhere, there's the red line. That's kind of interesting. But it's enough that I can see the intersection. So now what I need to do is I need to use the second trace, which gives me the calculate menu, and I want to find the intersection, which is number 5. Okay, and then so enter the first curve on the first line, so that's the blue curve. So you get a point kind of close to the intersection on the blue line here. We'll go a little bit closer. Alright, and then I would hit enter, and it's going to ask for the second curve, which is again some point on the red equation. Again, I want to try to get somewhat close to that intersection, and hit enter, and then I have to make a guess. So we, as normal, we just hit enter and ignore that, and the calculator will solve and find our intersection, which it intersects at x equals 10. So my answer for this equation for this problem is x equals 10. Now all I have to do is plug that back in to get my dimensions. So this cube would have to be 10 feet by x minus 2, so that'd be 10 minus 2, which is 8 feet, by x plus 4, 10 plus 4, which is 14 feet. So again, with these word problems, as long as you can set up the equation, we can use the calculator to graph it and find the intersection. Alright, you have some other practice problems to work out, and I hope this helps you understand what's going on.